Hi everyone, it's Mrs. Bebo. In this video, we're going to take a look at a few more story problems that involve two-step equations. These are going to be a little bit more involved than the last two videos with the story problems that they had. And so if you're really struggling with some of those more complicated two-step story problems, this is the video for you. Let's take a look at our first of two examples. The students at Worthing Way Middle School would like to rent a moon bounce for an end-of-year party. The graph shows the cost to rent the moon bounce for locations within the regular delivery area. To deliver the moon bounce to locations beyond the regular delivery area, the company charges a $50 delivery fee. Worthing Way Middle School is located beyond the regular delivery area. The students have $200 to spend. For how many full hours can they rent the moon bounce? We see that we have a $50 delivery fee. And so since they said it's located beyond the regular delivery area, that means they are going to be charged that $50. So that is something we're going to need when we go to write out our equation that we're going to use to help us figure out how many full hours they can rent that moon bounce for, right? Knowing they have $200 to spend. So they give us a graph in this story problem here. So if we take a look at this left-hand bottom corner of our screen, we have this graph that is telling us the relationship between cost and time. And we could pick any of the points on this graph, and they'll tell us all the same exact thing, that it boils down to this right here. It's $20 per hour. But again, if I looked at any of these other points, right? If I looked at this one here that I have highlighted in blue, it's $40 for 2 hours. Well, 40 divided by 2 is $20 per hour. I could choose this point here, 60 divided by 3, still $20 per hour, right? So there's a consistent relationship that's showing us that no matter which point we pick, it's $20 per hour. So that's going to help us out when we go to write our equation. So that's going to be our first step, is to actually write out the equation. So let's write the equation. And to start off, let's define a variable. So let h equal the number of hours, because again, as I have highlighted up there, for how many full hours can they rent the moon bounce? That is what we're trying to solve for, so that is what my variable should be. So let h equal the number of hours. We know we are being charged a $50 delivery fee. That's only happening one time. And on top of that, we're spending $20 per hour on this moon bounce house, right? So we're going to go through and set that equal to now $200 because that's the most that we have to spend. So just to help us with that information again, this was the delivery fee. This is the cost per hour. And this right here is the total we have to spend. All right, so now that we have our equation written out, we can actually solve it, right? So step one, write out our equation. 50 plus 20h equals 200. And our next step is to actually go through and solve it. So let me write that out. We're going to solve. Our first step is to get rid of that 50, right? That constant. So we're going to subtract 50 from both sides of our equal sign. So we'll have 20h equals 150. And then we're going to divide both sides by 20 next, because again, to get rid of what h is being multiplied by, we do the opposite, which is to divide by that same something. So in this case, 20. And then when we do 150 divided by 20, which we can think of as just 15 divided by 2, we're going to get h equals 7.5 hours. Now, this question does ask us, though, for how many full hours they can rent the moon bounce for. So we're actually going to say our final answer is 7 hours. If they didn't ask us for how many full hours, we could just call it good with 7.5. So always go back and double check what your question's asking for, because that made a big difference, right? So full hours versus how many hours? Full hours is going to be 7. All right, let's take a look at one more story problem here. That's going to be a similar type of situation where we'll have to do a little bit of work to set up the equation and then solve. On this problem, it says an electrician charges his customers an hourly rate for labor as shown in the table. In addition to the hourly rate, customers are also charged for the cost of materials needed to complete the job. If Mr. Duplain will be charged for 6 hours and $70 for materials, what is his total charge? So going through and highlighting some of this key information, right? We have this hourly rate, and we know we're going to be doing this for 6 hours. And then we're getting charged $70 for materials, and we're trying to figure out what the total charge is. When we set this up, we're going to actually use the table to start, to help us figure out, well, what is the cost for the 6 hours of labor? Because right now we can see that there's this relationship in this table between hours and the labor charge. So we're going to actually go back to something we did at the beginning of the school year, for my students anyway, where we're going to set up a proportion and solve for an unknown value. So we're going to use this table to find the cost for 6 hours. So I'm going to use, it doesn't really matter which pairing you use, but I'm going to use this one here, the 2 hours, and it was $43. So it was 2 hours for $43, and I'm trying to figure out how much for 6 hours, right? What was that cost for 6 hours? So as a reminder with proportions, which are actually a type of equation, right? We're going to do cross products to solve this. So we're going to do 2 times x and then 6 times 43. So we'll have 2x equals, and then 6 times 43 is 258. And then to solve this, we're just going to divide both sides by 2. And we find that x is equal to $129. So it was $129 for the 6 hours, which makes sense, right? If we're taking a look at that pattern, 6 hours should definitely be more than $107.50. So now that we know that for 6 hours that this is $129, we can go ahead and write out our equation. So we're going to say, I can just organize my work, writing out our equation. We're going to let T equal the total charge or the total cost. And then we have the 129, so that's the cost for the 6 hours, plus the $70 for material, and that's going to equal the total charge. So just to go back and label this so we know where we got all that information. Again, this was the cost. Oops, not for dollars, but it'd be 6 hours. 70 is the material cost. And again, T was that total cost. So this actually is more just a one step, right? Because now that we have that figured out, to solve it, all we need to do is add what's on the left-hand side together. So we just need to do 129 plus 70, which tells me it's $199 for T. So even though this question was set up to be, considered a two-step equation because it's within that section on two-step equations, it really wasn't too bad once we broke it down. So make sure you are thinking through the whole question, right? Highlighting that key information and looking back at some of that prior knowledge, like this one where we had to set up a proportion to solve for an unknown amount. So that's it for this video. Thanks for watching. And make sure you check out the other videos on two-step equations.